Welcome to Shiney Brain Academy. Today, we are embarking on a fascinating journey into the heart of matter itself. Every object you touch, every breath you take, and the very stars in the night sky are composed of tiny building blocks called atoms. These atoms are categorized and organized within one of science's most brilliant inventions, the periodic table. Prepare to unlock the secrets of the chemical universe. So, what exactly is the periodic table? It is far more than just a wall chart in a science classroom. It is a highly sophisticated, logical arrangement of all known chemical elements, ordered primarily by their atomic number, which is the count of protons in their nuclei. This organization isn't random, it is designed so that elements with similar electron configurations and chemical behaviors fall into the same vertical columns. The genius behind this organization was a Russian chemist named Dmitry Mendeleev. In 1869, he realized that if he arranged the elements according to their atomic weights and chemical properties, a pattern emerged. What made his work legendary was his bravery. He left intentional gaps in his table for elements that had not yet been discovered, correctly predicting their properties with uncanny accuracy based on their position. To understand the periodic table, we must first look inside the atom. At the center is the nucleus, packed with protons and neutrons, while electrons zip around the outside. The atomic number, which dictates an element's place on the table, is simply the number of protons. If you change the number of protons, you change the element entirely, transforming one substance into a completely different chemical identity. When you look at the periodic table, notice the structure. The horizontal rows are called periods, and each period tells you the number of electron shells an atom has. The vertical columns are called groups, and these are incredibly important because they group elements with similar chemical characteristics. Elements in the same group tend to react in similar ways, which is the cornerstone of predicting chemical reactions. The table is broadly split into three main categories. Most elements are metals, located mostly on the left and center, known for being excellent conductors of electricity and heat. On the right, we find nonmetals, which have diverse properties and are essential for life. Finally, running like a staircase through the center are the metalloids, rare elements that exhibit traits of both metals and nonmetals, acting as semiconductors. Let's zoom into Group 1, the alkali metals. These are some of the most reactive elements in existence. Because they have only one electron in their outermost shell, they are desperate to get rid of it to achieve stability. This makes them highly volatile. You will never find pure alkali metals in nature, they are always bonded to other elements, usually forming salts that are essential to our daily survival. On the far right of the table, we find Group 18, the noble gases. Unlike the alkali metals, these elements are perfectly happy. Their electron shells are completely full, meaning they have no need to gain, lose, or share electrons. This makes them inert or non-reactive. They are the monks of the periodic table, living in complete chemical solitude, and we use them in everything from neon signs to lighting. If you look at the large block in the middle of the table, you are looking at the transition metals. This is where you find the elements you likely encounter every single day: iron for steel buildings, copper for electrical wiring, and precious gold or silver for jewelry. These metals are special because they can use electrons from more than one shell for bonding, which gives them unique, often colorful properties. Sitting right next to the noble gases in Group 17 are the halogens. If noble gases are the commonest elements, halogens are the most aggressive. They are missing exactly one electron to fill their outer shell, so they are constantly hunting for an electron from other atoms. This makes them incredibly powerful disinfectants. We use fluorine in our toothpaste to harden enamel and chlorine to keep our swimming pool safe. You might have noticed those two detached rows at the bottom of the table. These are the lanthanides and the actinides. They are often placed separately to keep the table from becoming too wide. Many of these are the rare earth elements, which are vital for modern technology, from your smartphone screens to electric vehicle batteries. The actinides are particularly heavy, and many of them are radioactive and unstable. The true power of the periodic table lies in its strengths. Because the table is organized by electron structure, scientists can predict how an element will behave just by looking at its location. For example, as you move down a group, the atoms get physically larger because they add more electron shells. As you move across a row, the atoms get smaller and more electronegative, meaning they pull electrons more strongly. When you look at the periodic table, remember that it also describes the story of life. For elements, carbon, hydrogen, oxygen, and nitrogen make up nearly all of the biological molecules in your body. Carbon is the backbone of organic chemistry, capable of forming the long, complex chains required for DNA and proteins. Without the specific arrangement of these elements, life as we know it simply would not exist. Science doesn't stop with what we find in nature. In massive particle accelerators, scientists mash atoms together to create brand new elements that don't exist anywhere else on Earth. These synthetic elements are usually very heavy and incredibly unstable, decaying into other elements in mere milliseconds. While they have limited practical use today, they help us understand the fundamental limits of how much matter can be packed into an atom. The entire universe is held together by the way elements bond. When an atom from the left side of the table meets an atom from the right side, they often transfer an electron, creating an ionic bond, like the table salt you sprinkle on your dinner. When two nonmetals meet, they share electrons in covalent bonds to reach stability. This electron movement is the engine that drives every chemical reaction in your body. The periodic table is not just for academics, it is the source of all our modern technology. The silicon in your computer chip is a direct gift from the periodic table, chosen for its semiconductor properties. The lithium in your phone battery was selected for its ability to store and release energy efficiently. Every piece of hardware you use is a triumph of chemistry, based on knowing exactly which element to use and why. Because the periodic table is a predictive map, it allows scientists to design the future. Instead of guessing, researchers use the trends we discussed to invent new medicines, more efficient solar panels, and stronger, lighter materials for aerospace. When you master the periodic table, you aren't just memorizing names and symbols, you are learning the very syntax of nature, allowing you to participate in the creative process of chemical innovation. As we learn about the periodic table, we must also recognize its limits. Many of the elements we rely on for technology, such as cobalt and rare earth metals, are finite. They are not renewable. This creates an urgent need for better recycling technologies for our gadgets and a move towards sustainable chemistry. Understanding that these elements are limited resources is the first step toward a more conscious and sustainable future for everyone. The periodic table is a living document. Even today, scientists are working in laboratories across the globe to identify new, super-heavy elements that could expand the table even further. It is a reminder that science is never finished, it is an ongoing human adventure driven by curiosity, persistence, and the relentless desire to understand how our world works. Your journey into chemistry has only just begun today. Let's do a quick recap to lock in what we have learned. The atomic number is your key, acting as the DNA of the atom. Vertical groups are your secret code for predicting behavior. Trends like atomic radius and electronegativity tell you how elements interact. And finally, the wide diversity of metals, nonmetals, and metalloids provides the diverse materials that make up our universe, our technology, and our own bodies. Time to test your knowledge. Let's see if you were paying attention. We discussed elements that are perfectly satisfied with their electron configuration and avoid reacting with others. Look at your options. Alkali metals are highly reactive, halogens are aggressive hunters, and transition metals are complex. That leaves the group on the far right. Think back to our discussion on Group 18. Choose your answer carefully. Congratulations on completing our tour of the periodic table. You now understand the fundamental map of the chemical universe. If you enjoyed this journey into the atomic world, make sure to hit that subscribe button and ring the bell so you never miss a lesson. Leave a comment below telling us which element is your favorite. We have so much more to explore together in our upcoming science series.